So let's get into it. Let's actually make a thread here. So let's make a new class, vi.rubyos.rb. Okay, so if we want to make a thread in Ruby, then first off, we're just going to look at the thread class, and we can use a variable, or it doesn't really matter. Let's just do v is equal to thread.new for the sake of brevity, it doesn't really matter. One important thing is that when you make a thread, pretty much whatever you're going to do within the thread, you have to place within the block. So whatever I want the thread to do, I'm going to put in the block. So let's do a puts mid, just the simplicity. Let's do a puts big and a puts end. So what we want to print here is beginning followed by mid followed by end. And this shouldn't actually work because I'm missing something important. So let's see if that works. Just cool. So it shows beginning and end. We are missing something, and that is the join method of thread. Basically what the join method does is that it allows for the thread to continue running after the main thread has stopped. So in this case, what's actually happening is that beginning is running, end is running, and then thread is not actually going to be able to run because the program is effectively finished. So if we call join, it'll allow the thread to continue running after the main program is ended. So that's what we want to do. And so now we're going to go ahead and run that again. And voila, we see beginning, mid, and end. Okay, so now let's go back to the class that we just made. And let's get into something just a little bit more complicated. So let's go ahead and make another thread. Thread.new puts, and we'll do this as mid2. Okay, so originally what you might expect this to print out is mid2. And I'm sorry, from the very beginning it would be beginning, mid2, and then end, right? And you would be right to assume that. Again, don't forget to join. So let's do x.join. Let's run it. And yeah, if you expected that to work, that's what will happen. But how might you use thread classes to change things around a little bit? Well, there's a sleep method in thread, and if you're familiar with bash, or if you've been on like Jira, you'll probably know what this does. So this is going to effectively put the thread to sleep. And when we run this again, what we're expecting now is instead of the begin mid to end, we should expect to see a big mid to mid and then end. So let's take a look at that. And yeah, so what happened there was the mid to thread actually was able to run before the mid thread was able to actually relinquish control. So with that out of the way, let's go into something even more complicated. So we're here with this program, and we have it's a bit different from the last one in that it has an integer basically, and these threads are actually going to be modifying the integer, and they're going to be printing out integer values. So this is especially kind of strange if you think about threads. In that you're actually going to be modifying data. Have this thread is changing temp to 2. We have it sleeping for 1 second, and then we have another print statement with something else to help us figure out where we are, which also prints out temp. So what do we think this is going to print out? Well, if we analyze this, it may print out, let's see, it may just sequentially, it may print out it would be, let's see, it would go from 3 to a 2, back up here, and then it may print out a 2, and then may print out cat, and then it may print out high, and then 2 again. So let's see if it does that. Okay, so let's look at our output with that. So it printed out a 3, cat, high, 2, and end. So it didn't actually print out what we were expecting it to. This is actually going to lead us into an issue that kind of stems from safe threading, or thread safety rather. And if you've taken a class like 335, you may have kind of touched on this a little bit, or if you've just looked into threads at all, you probably know what this is. So really, what this is going to come down to is that we're modifying information and we're printing information, and things are just going to be weird, and threads are a mess when it comes to consistency like this. Uh, there is a solution though within Ruby, and that is effectively the mutex class. So within the mutex class, we'll see that you can think of it something like a library in that it gives structure. So there's effectively one person or one thread in this case is going to be accessing data, and they're going to, in this case, you can think of it like a book, and they're going to check it out, and then when they're done with that book or with that data, they're going to check it back in. And then the next thread or the next person can check that book in, etc., etc., etc. And so let's go ahead and look at another example of this right now. So we're here with another example. So this is going to have an array. It's going to have 5 threads, and each of these threads are going to run 100,000 times. And so what this is effectively going to do is it's going to display to us that there is a problem with multi-threading here, and we need some kind of thread safety. So what we would expect, or what we want this to do, is that we're going to want all of the indices in this in array, everything within those indices should be 50,000, or sorry, 500,000, because this is running basically effectively 500,000 times. The counter is running up 1 each time, and so it should run 500,000 times, and so everything in this should be 500,000. If we run this though, we're going to see that that's not actually the case. So we're going to see 50,000, 50,000, 45, or sorry, 500,000, 450,000, etc., etc. And that is because these threads are sometimes running slowly, and it's just threads sometimes run slow, sometimes run fast, and they're running at different times. And so counts are being changed and accessed at different times when they shouldn't be. So the way to actually stop this is, if you see at the top, there's mutex is equal to mutex.new. So we're instantiating a mutex class, and we're going to use the synchronize method of that class. So basically what we're just going to end up doing here is we're going to do a mutex.synchronize. And so the solution to all of these kinds of situations where you have a problem with data and you're accessing it, so any kind of thread safety, you're just going to call a mutex.synchronize on anything where you're reading or writing to data, and so that should fix the problem. And voila, we got 50,000, 50,000, 50,000, 50,000. And that's it.